It's important to be thinking about hydrogen's properties when designing a new facility. Understanding the characteristics of hydrogen has important safety implications. People working with hydrogen should understand that hydrogen is colorless, odorless, and non-toxic.
Hydrogen is prone to leakage and diffuses through many materials. It's buoyant, and being the lightest gas, it rises quickly under atmospheric conditions. It diffuses in air rapidly, and it's highly flammable, easily leading to fire or explosion. It burns with an almost invisible flame, and it can cause hydrogen embrittlement in metals, leading to component failure. Those characteristics must be considered when planning and designing the facility.
When building or repairing piping systems, find ways to keep interior surfaces free of dirt, cutting oil, and metal chips. These can cause trouble for valves, compressors, and other critical components. Consider where to use filters, too. Hydrogen piping should not be left open to the atmosphere. To keep air and debris out, any pipe opening should be plugged, capped, flanged, or routed to an appropriate hydrogen vent stack. The best way to disperse small leaks from fittings and joints is to route hydrogen piping outdoors whenever possible. It's not always possible, though. When routed indoors, piping should not be covered by walls, floors, or ceilings. It should be readily visible for inspection and protected from physical damage. If placing piping underground, consider protection from external corrosion, guarding against inadvertent excavation, and using welded joints or no joints at all to reduce the chance of any hydrogen buildup in an enclosed pocket or space.
The following information should be posted at the entrance and exits of any workspace where hydrogen is used or stored, in clear view of all who enter. The name of the workspace and the room number, the activity being conducted, the names of all principal contacts, such as the principal investigator or supervisor, along with their contact information, the name and address of the building, emergency response and call information, as well as multiple emergency evacuation routes, identification of all hazards present in the workspace, and a map showing the location of hydrogen storage, as well as the primary and secondary gas shutoffs.
When arriving on the scene of a vehicle fire, every attempt should be made to identify the vehicle type in order to properly control the incident. Identification may be difficult because fire or other damage may have rendered exterior identification badges invisible. Always treat vehicle fires as involving some type of alternative fuel until proven otherwise. Fires in fuel cell vehicles are extinguished in a manner similar to conventional and other alternative fueled vehicles. Always wear full firefighting PPE with SCBA. Water is the most effective extinguishing agent. Stretch a hose line and approach the fire from a 45-degree angle. When safe to do so, attempt to prevent vehicle movement with wheel chocks. The electricity in the high-voltage system is not transferred through the water stream back to the firefighters. However, do not come into direct contact with high-voltage components with the nozzle, hose, or your body. When forcing the hood open or attempting to gain a space to insert the nozzle, be careful not to come in contact with high-voltage components under the hood. If the hydrogen cylinders are not involved, extinguish the fire in a manner similar to a conventional vehicle. However, if there is significant flame impingement on the hydrogen cylinders, it may be best not to attempt to cool them. Cylinder orientation in the vehicle may impede complete cooling, while water application can prevent activation of the TPRD, leading to cylinder failure. From a safe distance, continue to apply water on the vehicle to extinguish the fire and protect exposures. If venting hydrogen is ignited, let it burn. Do not attempt to extinguish it.